Alright guys, so this starts our first unit, chapter 1, where we're talking about functions and their graphs. The first topic is out of lesson 1-3 in your textbook. It is called linear equations and two variables. A lot of this is going to look like a review to you. You should have seen most of this information in algebra, maybe algebra 2 or elementary functions, whatever class you are coming from. A lot of this is going to look very familiar, but it is essential that we go through it, refresh our memories so that we can be prepared for what's to come in the pre-cal sense of where do we need to learn how to graph linear equations and so on. If at any time during the video you feel like you need to go back and review something, you have that ability to do so. If you want to try something before I do, just pause the video. Otherwise, I'm going to work through the problems and I will give you cues as to when, if you want to try something on your own, would be a good time to pause. Otherwise, we're just going to go right on through to give you a supplement to the notes and prepare you for the lesson that we go over together and give you the opportunity to ask any questions. So here we go. We are talking about section 1-3 on linear equations and two variables. The first thing and the most familiar to a lot of you is what we call the slope-intercept form. What is the slope-intercept form? Anytime you ask somebody, what is the equation of a line? First thing that comes to mind is y equals mx plus b. Now, the graph of the equation y equals mx plus b, as it says, is a line whose slope is m. So the slope of the line is m. And in the equation, there it is, there's m. And the y-intercept is 0, comma b. Y-intercept is 0, comma b. You will see b in the equation, but you don't see the 0, comma. But think about it. Where something crosses the y-axis or vertical line, what is the value of x? And that is 0. So that's why the point, the y-intercept is 0, comma b. In the equation, you'll just see it simply as a number that's either added or subtracted to the slope times the value of x. The equation of a vertical line is always in the form x equals a. And why is that? Why can a vertical line not be written in the form y equals mx plus b? Why is it just x equals a? What we look at in those situations is the fact that in a vertical line, x equals just the number. Because y is not involved, we say that the slope is undefined. We can say it has no slope, but we cannot say that the slope is 0. That's a different thing. A slope is 0 is a horizontal line. A vertical slope you cannot climb. It is undefined. So let's take a look at a couple of examples in graphing. So example 1, we're going to sketch the graph of each one of these. And we have 3 methods for you in which we can graph. The first one, A, is in the form y equals 2x plus 1. So the easiest way to graph equations like this is to literally start at the y-intercept. In this case, the y-intercept is 1. So I'm going to go to my graph here, and where it crosses the y-axis, or x-axis, the y-axis at 1, I put a dot there. Then I look for my slope next. The slope is the number in front of x. The slope is 2. Now, 2 as a slope is really rise over run. We call that 2 over 1. So 2 over 1, that means that from that point, I go up 2 over 1. And then place a dot there. I can do that again. Up 2 over 1, place another dot there. And do it again. And you can keep doing that as many times as you want. And eventually you can connect those dots to create your line in between, or going through those points that you've plotted. That's graphing using the slope-intercept form. It's in y equals mx plus b form already. Why not? The next one is a little trickier. Kind of works the same as A. Whereas, I'm going to graph y equals 2. So I can go to my y-intercept, which is 2. That's my y-intercept. I can do that. The problem is I don't have x in this equation, so I don't have a slope. Technically I do. The slope this time is not undefined because it's a y equals. That's a horizontal line. So the slope in this case is 0. That means I go up 0 over 1. Up 0 over 1, but that really doesn't make any sense. Instead, one way I like to think about it is if I'm graphing this myself, I look at this graph, and when I create the axes and then I put the little tick marks, I notice that the tick mark for the y-axis runs left to right. So why not utilize that? So I'll go in here and I say, okay, that tick mark runs left to right, so that means that my line has to run left to right. That also tells me that in that equation, in that graph, y never changes from the value of 2. That is why it's at a horizontal line. Y equals 2, because it is. The next one is going to graph a little bit differently. As you notice, this one is not just in one variable. This one is not solved for y, so you got a couple of options. If you really want to, you can go ahead and solve for y yourself. But in situations like this, one easy way to graph those is to graph by what we call intercepts. That's using both the x and the y intercept. So to find the x-intercept, that's when y is equal to 0. So for the x-intercept, so we're going to take this one over here. For the x-intercept, we say y is 0, so that means that y, anything associated with it, is gone. So x equals 2. So for part C, x is equal to 2. So I can put a dot where x, and x only, is equal to 2. Now to find a y-intercept, I'm going to go over here, and for the y-intercept, I'm going to say x equals 0. So any portion of that equation involving x is equal to 0. It's literally gone. I emphasize bringing the plus down because if that's not a plus, or if there's any other number, if that's even a negative in front of the y, you kind of can't forget that because it does change things. But in this case, that plus y really doesn't make a difference, so I can go ahead and erase it. But in the situations where you might have a negative or a number, please make sure you bring that down. So we find out that the y-intercept for part C is also equal to 2. So I can go to the y-intercept where y equals 2 and put a dot there. Now notice I have 2 dots on my graph, 2 points that I've plotted that I can literally connect with the line. And then I now have graphed using the intercepts. Alright, so 3 options. 1, the slope intercept, that's A, with a simple follow the tick mark, and that works even for x equals lines. Follow the tick mark, that's graphing using vertical or horizontal lines, or the one where you have to graph by using the intercepts. Now, if you don't like the way we graphed C, you can go back and change the equation to y equals, and you can solve like or graph like you've done for part A. All right. So here you have an opportunity to graph and sketch these on your own. What I'm going to do at this time is advise you that if you want to try this, go ahead and pause the video. Otherwise, I'm going to go ahead and graph these for you and show you what these should look like. So pause now if you would like to try. Otherwise, here we go. So part A. Oh, and the board did something funny there. So part A. We have y equals negative 3x plus 2. Well, it's telling me that this is in y equals form. So when I go and draw my graph, 1, 2, 3, the biggest number I see is 3, so why not? 1, 2, 3, 1, 2, 3, 1, 2, 3. It's telling me to start at the y-intercept of 2. Then it tells me to apply a slope that reads negative 3. Well, it's really negative 3 over 1. So from that point, I go 1, 2, 3 down over 1 and place my next point. When I'm done placing those 2, I simply connect those with a line. If you would like, you can draw more points, but you don't have to. 2 points, as long as you know what the line looks like, that should be sufficient. The other option you have is creating a table of values, and sometimes it's actually even more helpful. Alright, so then part B. For part B, we're going to go over here and say, well, this one simply reads y equals negative 3. I can graph using the intercept or the tick mark method, and here we go. This is what I mean by the tick mark. I'm creating this grid completely on my own. Here's my axes, and I start to count. The biggest number I see is 3, so I go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. You don't have to do all that because you know exactly what this one's going to look like. I go to where y is equal to negative 3. In this case, y is negative 3. I go down here, 1, 2, negative 3. Look at that tick mark. You see how that tick mark runs left and right? That means that my line, because it does not have x involved in it, it is a horizontal line that runs at negative 3. Y can never be anything other than negative 3. Then we have the last one, which is part C. This one is a little trickier. You got a couple of options. Again, you can solve for y, or you can use the intercept method. This one, it might actually be easier to solve for y, because if I try to use the intercept where I cover up, say I cover up right here, where I say, okay, the y is not there, that reads 4x is equal to 5. Then I have to solve for x. It becomes 5 divided by 4. That's just not nice. It becomes a fraction, and most people are afraid of fractions. Matter of fact, 5 out of 4 people have trouble with fractions. And so the best option that we have here is to take our 4x plus y is equal to 5, and then move this to read y equals. So I'm going to subtract 4x from both sides, minus 4x. So then I end up with y equals negative 4x. Remember, you cannot combine those two. They are not alike. And then the 5 is positive, the 4x is negative, and I should put the x first because it's just convention. That's what we normally do. So now that's a lot easier. I can go back and graph just like I did A. You can use the intercepts, but remember, there's not a way that you always have to. You have options. So in this case, the biggest number I see is 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's just the way I graph. I use the number I see and then go from there. And then I start off at the y-intercept. This time the y-intercept is positive 5. So I go up here, put a point there. Then my slope is negative 4 over 1. Then I go 1, 2, 3, 4 down over 1. And you can do that again if you want. 1, 2, 3, 4 down over 1. This is a little steeper, so it might be a good idea to add that extra point, just for fun. And then you connect those points with a straight line, and that's what your equation should look like when you're done, roughly. All right?